Hello, good morning. Sorry I'm late. I think everything is okay now. Do you see the desktop and hear me? Does everything seem right?
Yes.
Yeah, everything's
Okay,
right.
good,
Yes.
thanks. Okay, let me, okay. First thing, remember that the exam is Wednesday. That's this Wednesday. So first, is there anybody who has any question about the exam, especially about the review problems? Or any questions that come up over the weekend about the exam or the review? Oh, so it'll be like, it'll be on Brightspace. You'll download it from Brightspace. Oh, let's see. The exam, I'll make it available right after class. We'll do, I forgot to say how this will work. What we'll do is we'll have class on Wednesday, and then the exam will be up on Brightspace right after class, and you'll have till 11 o'clock in the evening to finish it. Okay, so I'll give you the whole rest of the day to do it. So we'll meet from 12:30 to 1, and the exam will be, you can download it, and if there's questions about the exam on Wednesday, we can use time on Wednesday to talk about uh, the review problems. But the exam will be available at 1 o'clock, and you'll have till 11 o'clock to finish it. Okay. Oh, is it time? Yeah, till 11 o'clock. So the answer is it timed? Yes, till 11. Yeah, it'll be due at 11. So yeah, I figured that's, because I've noticed, talked to other professors. There's lots of problems with scheduling exams. So I think this is what I've been doing with my other classes, and it's worked pretty well. Now, it's an exam. You're on your honor not to work with other people. You obviously you'll have your computer and resources to work on the exam with, but you're not supposed to go talk to other people in the class and ask them for their solutions or anything like that. Okay, so it's essentially an open book exam. Okay.
um, I think someone else asked in the chat, are we, once we open it, do we only have an hour and
No,
15
no,
minutes?
it's just going to be a PDF document. There's no mechanism for timing it or anything like that. It's just it'll be a PDF document. You'll download it, you'll write your answers and scan the exam back in, and then upload it back to Brightspace.
Gotcha. And is there any restricted file types, like?
Yeah, Brightspace wants PDF files or Word
Gotcha.
documents. There'll be an explanation of that with the exam. Yeah, but Brightspace wants PDF or Word documents. So that'll be part of the exam. I'll give you a little explanation of what you need to do. There's some, and then the exam will be graded on Brightspace. So if you upload a PDF to Brightspace, I can grade the exam directly on Brightspace. So Brightspace wants PDFs or Word documents. Okay.
Do you know how many questions will be on it yet?
Oh, like 10 or 12. 10 or 12 is usually about the right number for it's meant to be roughly an hour, hour and a half exam. Actually, it's more or less to be the same exam I gave in class, but because of how strange this all is, I'll make it available at 1 and it'll be due at 11. So if you can do it right away, feel free. If you need to wait, if you have to go to work or do something else, you can come back and work on the exam. Okay. And I'll be available for questions during that time. Like if somebody wants to send me an email and ask a question to clarify a problem, I'll try to answer the questions as quickly as possible. Because sometimes sometimes I will misword a problem. There'll be a little mistake on the exam. So it's pretty reasonable to have a question about what's on the exam. Is this, to ask for some kind of clarification on something you might think is either wrong or not quite clear. So I'll try to answer questions during the exam as quickly as possible. So during the exam, you can ask questions essentially by email. Okay. Okay, so like I say, we'll meet on Wednesday, and then the class period will be a time, one more chance if anybody wants to ask a question about something in the exam, and then the exam will be available from Brightspace at 1, and then it'll be due back at Brightspace, and you'll upload your PDF or Word document back to Brightspace by 11 o'clock in the evening. Okay. Other questions or any questions about the review problems?
Yeah, can we go over how to draw the diagram in problem 6?
Okay. let's see, let me pull up Paint. Let's see if I can get them both to fit in. Yeah. I can't really, there's not room for both, but okay. Kind of work our way through it. A process P1. Okay, there's a process P1. So let me draw a box. Oops, wrong tool. Let me draw a box. There's a process P1, and the key idea is that it's got standard in, standard out, and standard error. So I'll put those into the picture. I'm going to connect those to things. And standard in is also numbered 0, standard out is numbered 1, and standard error is numbered 3. Those numbers are often used for them. Instead of writing standard in, standard out, and standard error out, to make it easier, I'll write 0, 1, 2. Okay, right. So I create a process, and it's got an input and 2 outputs. Okay, and I'm going to be, as the picture goes along, I'll be connecting these to other things. Okay, then it opens file A1 for input and opens file B2 for output. So that makes 2 more connections. So I'll draw it like here. There's a file A.text, okay, and another file B.text, and there's a connection. This is open. This is open in the file, the process. So do it like this. So there's A going into the process and B going out. It turns out these are actually, these will be numbered now. It doesn't really matter, but in fact, this wouldn't be numbered now 3. This is the third connection. It's got the number 3 associated with it. Windows doesn't use these numbers, but Linux uses them all the time. In Linux, you make use of these. Windows has these numbers for like standard in is 0, standard out is 1, standard error is 2. If you open a file, the next file you open will be 3. The next file you open will be 4. Windows lets you use those numbers if you want to use them, but Linux makes real use of them. But they kind of help keep track what's going on here. So and this is actually for input, so I can draw like a little arrow. Let's see. This is, it said it opens, P1 opens the file A for input. It opens the file B for output. So if I want to put a little arrow there, there's actually an arrow tool. I could have used the arrow tool, but this is going out. So this is, there's a little, this goes out to there. Okay. So that's what my picture so far. Then the process creates a pipe. Okay, so I'll draw the pipe as a little, here's a pipe. It's a little box. Data flows into it and flows out of it. Okay, so there's a pipe. Okay. Okay. Now, then here comes the tricky part. P1 creates a child process, P2. Okay, so let me just draw that in the picture. P2 like P1, I'll draw a process. There's a process. This one is P2. It's got standard in, standard out, and standard error. So it's got something coming in here and something going out here and out here. Okay. Now, the tricky part is to read this. With P2, inheriting just means it's connected to the same thing. So it's connected to A, the pipe's input and P1 standard error as its standard in, standard out, and standard error. So you read that in parallel. Okay. P2 with P2 inheriting a.text as standard in. Okay. So it inherits this connection. It inherits this connection here. Like this. Okay. So the input to P2 is this file. This file. Now that what that means in this picture right now is that this process and this process can both read from A. Now eventually we'll see that there's something's going to change, but what in this picture what that means, and you can actually do this, that either one of these processes can read data from A. Okay. So A's data is available to that process and it's available to that process. Okay. So this is connected to its standard in. Okay. If I want to draw a little arrow, that's going in. Okay. Now the next part of the sentence. P1 creates a child process P2 with P2 inheriting a.text as in, the pipe's input as its standard out. So what that means here is this standard, this guy here, the standard out is connected to there. Okay, like that. So his output goes into the pipe. Okay. Okay. And then his standard error gets connected to his standard error. I'm not going to show that because right now it'll make the picture too messy. But then the last thing I said was, and P1 standard error as standard error. So P2 needs three things. P2 inherits an input, an output, and a standard error, and they are, that's its input, its output, and its standard error. Okay, so child process P2 with P2 inheriting a.text, pipes input, and P1 standard error as P2's standard in, standard out, and standard error. Then it does the same thing for P3. Okay, so you read the same thing. P1 creates a child process P3. So I would draw another process in the picture. Okay, so another process. This one is P3. And it's got its own standard in, standard out, and standard error. And they have to be connected up to something. Okay, and it says here that P3 inheriting the pipe's output, that's its input, B is its output, and P1 standard error as its standard error. See, as its standard in, standard out, and standard error. So it's the three are pipes output and B is input and output. So this input, oh, it's connected to this pipe. So this pipe just goes into there. So the output of the pipe becomes the input to P3. Okay, and then P3's output was P3's output goes to B.text. Okay, and erase some of these little marks I put here. Okay, right. So again, that sentence said that P1 creates another child process P3 with P3 inheriting, which just means it's connected to the pipe's output as its input. So what comes out of the pipe now goes into P3. B as its output. So the output of P3 gets stored in the text file along with anything. Notice that both this process and this process can store things in B. So if this one writes to B, it gets put in there, and if this one writes to B, it gets put in there. So B would be a mixture of stuff from this process and this process. And there's, you can do that in programming. You can have a file being opened in two processes, and both processes are just putting stuff in the file. Okay. And then the standard errors are all connected together. So I could do that now by doing this. This standard error is connected to this standard error, and this standard error is connected to both of them. So all the standard errors are connected together. So all the standard errors, they're out, all the data written to standard error goes to the same place, wherever this is. Wherever that is, all three of them print their error messages to the same place. Okay, so the operating system makes use of this idea that a whole bunch of programs can be dumping data to the same place. So the error messages from him, the error messages from this process, and the error message from this process all appear wherever this is, probably the console. And since we didn't say other, standard error is going to be the console if you don't say otherwise. Okay. And this standard out will be the console if it doesn't say otherwise. Okay. And this standard in will be the keyboard. If nothing else says otherwise, this would be the keyboard. Okay. So that would be the picture for this. Okay. Oh, no, then there's one last step. Then P1 closes its connection, its handles to A and the pipe's output. So what that means is that at the end, P gives up its ability to read from A. It closes that connection. So it gives up the ability to read from A. So only now P2 is reading from A. Okay. And I didn't draw it in the picture, but there was a connection from this pipe. When this process created the pipe, probably should have put them in there. When the process created the pipe, it got connections to the pipe. So the process got a connection to both ends of the pipe. Okay, and that would be numbered, those would be connections numbers 5 and 6. Okay, so when the process created the pipe, it could send data into the pipe and read data out of the pipe. So it closes its handle to the pipe's output. So it closes, I'll just show it, let's see. It breaks this connection here. So it can't read from the pipe's output. Okay, so now you have this is the picture that the program creates. There's a pipeline between what this process is reading A, sending it through the pipe into P3, and P3 is sending the data back to B. So A is being filtered through programs, and the results sent to file B. Okay. There could be something else in B coming from process P1, maybe, maybe not. But the key idea is that all the P2 will read A, do something to A's data, send it through a pipe, which is a filter, just like you did in like the homework exercise. This acts like a filter. A reads stuff from P2, reads stuff from A, sends it through the pipe to P3. P3 processes some more and then stores the result in text in B. Okay. A funny thing is that if P1 wants to contribute to the pipe, it can. Okay. And if P1 wants to contribute to B, it can. So P1 can still write to the pipe, which will then go through here and into B, and P1 can write directly into B. Okay. All right. So this is the idea of what these words mean. Okay. This is what the words mean. And then I'm not sure if we'll get a chance to do it later in the semester, but in the past, sometimes we would see how to write the code to do this. Like we haven't seen how to write all the code that would do this. Okay. But in the past, we sometimes would cover how we would write this. Here we're just talking about the picture of it. The idea is just practice and thinking about a process has connections. So people draw these pictures to keep track logically of what's going on. And then there's a way to do this in Linux, which we're not doing the Linux operating system. And there's a way to do this in Windows. Yeah, there are function call. Every one of the steps here is a function call in Windows. Like, you know how to open files, but we haven't seen how to create a pipe. Okay, there's a function call for creating a pipe. And then there's functions for doing these things like connecting P2's output to the pipe's input. That's a function. Connecting the pipe's output to P3's input. That's a function call. So there's function calls that set up these things. Okay. And making P3 inherit B from P1. That's a special function call. Okay. So this is the picture of this is the idea. You can clean up, let's see, let me save this before it gets lost. This thing can be cleaned up, but there's not enough room in there. So let me draw it again. If I can. When this is all done, you can simplify this picture a little bit. I'll do it real quick. Here's P1. Here's P2. Here's P3. Here's the pipe. Okay. This one goes out from here into the pipe, then from the pipe into here. The input here is a.text. The output at the other end, the output here is b.text. Okay, so all this messy stuff here, A goes into P2, out of P2, into the pipe, out of the pipe, into P3, into B, is just this pipeline here. Data goes from A into P2, through the pipe, into P3. So this is P2. This one's the pipe. And this one is P3. Okay, now, and then what's the rest? There's a keyboard going in here. There's output here going to the console. Standard error is, all the standard errors are connected. And then what the last thing is that this process can send data to the pipe. That's this number 5. That's this connection 5 here. And this process can also send data out to this process can send data to B. Okay, so there's the cleaned up picture. Okay, when you clean it up a little bit, it's a little bit easier to see what's going on. Okay, this one would be the keyboard. The keyboard will go in here. This is the console window. And last, the standard error. The standard error of this is also going to the console, and the standard error of this is also going to the console. So just right, they're all connected together, so they're all going to the console there and console there. Okay, so there's the cleaned up version of the picture.
Professor, the cancel is the error, right?
Pardon me?
The cancel is the error.
Yeah, right. So if I put the little numbers, this is standard in, standard out, and standard error. And oh, and this one, yeah, this one here is console.
Yeah, that's what I was.
Yeah, yeah, and usually the way I would do this is just show it as being, Usually in the picture, I would just draw it the following way. It just connects up to there. They both go into the console like that. Okay, just like that. These two connect into the console. Okay, it's just like, see, this connection here means that this thing can write data to the pipe and this one can write data to the pipe. Okay, so again, here, this is 0, 1, and 2, and this one is 0, 1, and 2. And this one here is actually, what was he? That was 4. This one's connection 4. Those connections 3 and 6 were closed. Okay. Okay. So there's the cleaned up. That's the same picture. That's the same picture as this one, but a cleaned up version of it. And you can see the structure much easier. That the parent created a pipeline that would process data in A and send it to B. And this is how, this is actually literally what a lot of big data systems are programs like this P1 that set up pipelines between other programs to process data. And there's huge amounts of tools out there in the world these days to make it easier to write code like this in Python and Java and JavaScript. To, instead of using real low-level Windows functions like we're doing, we're thinking here, there are tools that make it easier to write code that say that this process can create a pipeline to process some data, send it through some processing stages, and get the result over here. And sometimes these pipelines can be 10, 12 stages. There can be process pipe, process pipe, process pipe, process pipe. And these processes are pre-written tools that do data analysis. Okay, these are usually stages that do some sort of cleaning the data, processing the data, filtering the data. Okay, and then the pipes just are the things that connect one stage to the next stage. Okay, so this is the idea of a process creating a pipeline for the purpose of processing some data. Okay, okay, all right. Like I say, we probably won't have time this semester, but it's not hard to learn how to actually write the code that actually creates this situation here in Windows. So it's messy in Windows, and then it's people, because it's messy to do this in Windows, people have invented libraries to make it easier to do this for Python and JavaScript and Java. Libraries that make it easier to write these big data pipelines, or just these data pipelines. Okay. All right, so that's there's the rough picture. Yeah, this is the picture you get when you draw as you're thinking. Okay, so this is the picture. Yeah, even though I knew what the picture was at the end, I wouldn't draw it like that because that's not how you would analyze it. You would draw the picture this way by saying, okay, the problem said create a P1, then the problem said create a P2, then the problem said create a P3. So you just put them on the paper. Then there's a pipe, and then you put it on the paper, and then it starts saying how to connect them up. So you just kind of connect them any way you can. And then after you've connected them up, then you look at the picture and then try to figure out, well, what's it really doing? And then you could redraw it in a simplified form. But the drawing in the simplified form comes after you've figured out what are all the things it wants done. What do all the steps do? And then unravel it and see that that's what they create. Okay. Yeah. All right. Okay. What about other questions what about other review problems from?
I was going to ask about drawing 7B,
7B.
the diagram. Yeah.
This one here?
Yes.
Oh, this is the one that distinguishes between built-in commands and non-built-in commands. Okay. So let me close those. Okay, so when you have a command like this, there's a parent process. here that is CMD. This is CMD. CMD is creating, CMD is right now, see, if I, see, I'm running CMD. So when I type a command here, like dir, the CMD runs dir, okay? Okay. Now, in fact, that's one of the keys is there is no program dir. So we'll see what I mean. There is no program on the computer called dir.exe. So when I type dir, something a little bit different happens. But then there's a program called find. Okay, so find like X. Now what that program's doing, now I'm running the find program. In my input, it's looking for X's. So if I type something with an X, see, it repeats it back. It says, oh, I found an X in that last line. See, there's no X in that line, so it didn't find an X. There's no X in that line, so it didn't find an X. There's an X in that line. There's an X in that line. Okay, so the find, now I'm running the find program. Okay, now what if no, Control Z gets me out. What if I say dir and pipe the result into find X? Is there any X's in dir, in the output from dir? So that takes the output from dir and puts it through find to say, are there any X's? Oh, and I need quotes around the X. Okay, and yeah, there were 2 lines in the output from dir that had X's in them. Okay, now what kind of pipeline was that? Okay, what kind of draw, now CMD had to run the find program. Okay, so CMD created the find program here. So that would be find.exe. Okay. Okay. Now, the find got its input from somewhere. Now I know that find got its input from a pipe. So there's a pipe here. Oops. So find got its input from a pipe. Okay. So somebody had to be putting data into the pipe. Now, the data was supposed to come from dir, but dir is a built-in command. What that means is it's CMD that actually does the dir. So we can think of dir as just being a function inside of CMD. dir is actually just built into CMD. So it's CMD, what it did, CMD is it created its own little connection. It created an extra connection to that pipe. Okay. Now the output from the find went to the console. Okay, and this guy, the output of him is going to the console, and the input from here is coming from the keyboard. Okay, so CMD gets its input from the keyboard. It sends its output to the console, and find was sending its output to the console. Okay, so there's the picture. And then this guy, I'll label, this one is a pipe. That's what CMD built. CMD built a pipe, and it started find. Just like an example we did a minute ago, it made it so that the output of the pipe was the input to find, and the input to the pipe was this extra connection. So if this was numbered, if this is 0, 1, and then standard error would be standard error would be 2. This one's actually going to be number 3. There's a third connection. So CMD had to create an extra connection for itself to the pipe. It did the dir stuff and sent it through the pipe, and then find read things out of the pipe and did the finding, and it found the lines with the X's in them. So the dir data actually came from CMD. That's what we mean by built-in commands. Okay, now if you go to this web page, it's kind of useful. These are really useful things to know eventually as you become a sophisticated user of Linux or Unix and Windows. It matters a lot to start knowing the internal way all this stuff works. These are all the things that CMD can do that are actually built into it, that aren't programs that it runs, that they're actually things that are built directly in it. So essentially, every one of these is a function in CMD rather than a program that CMD starts up. Okay. And if you look at this list of all the CMD, if you look at this list of all the commands you could type at CMD, he kind of clever. He put a little dot next to the ones that are built in. Like that one's a built-in command. That one there, that's essentially a function built into CMD, or not a program the CMD calls. This would be a program. If you look on the hard drive in your, usually like change this, like look at take this one, CHCP. It's not built in. So if I go, if I where, oh, I'm sorry, I opened on my other monitor. Okay, here's my computer. If I look at my C drive, look at the Windows folder, go to the System32 folder. It should be in here. Well, there's one version of it. See, it's actually called chcp.com because it's an older program. See, but it'd be in here. Yeah, another one like Cipher, Cipher. That should be in here too. Not all of them, but they're usually, am I missing it? Oh, no, that one's not in this folder. Most of these ones that are not built in, they're usually in this folder here, the System32 folder. That's where the vast majority, no, I didn't see. There it is. There's Cipher. Okay. Okay. So these, so if you create, now a find is in here. There's find. Okay. So that's the program that was used to create that process. Okay. That was the program used to create that process. So CMD, when it read your command on the command line, when it read that command on the command line, it launched, and then it used the create process, just like you did in homework. CMD called create process to launch that. Now, it also called a function to create the pipe, which we haven't learned how to do, but there's a function to create the pipe. So it would create the pipe first, then it would create find, and it would have find created connected to the pipe. Okay. And actually, I can show you, you kind of have a sense of how this would work. Go to create process function, and you know about using the creation flags and the startup information block. Okay. Let me go to the startup information block. Startup info structure. See, there's where you could set standard in, standard out, and standard error. When you create a process, one of the things you can put in the startup information block, when you create this process and say, oh, here's what to connect standard into, here's what to connect standard out to, here's what to connect standard error to. So so in this case, the pipe would already be created. So when find is created, the standard in of find would be the output from the pipe. So the pipe gets created first and then find is created. And you use this piece of data, you use, it's not really a function, it's an entry in the startup information data structure that says, here's what standard in, standard out, and standard error should be. If you don't set these, standard in is the keyboard, standard out is the console, and standard error is the console. So these default to the three standard ones, keyboard, console, console. But when you call create process to create find, you can make this connection here. Okay, and so you call the function to create a pipe. After you create the pipe, you got a connection to the input and the output of the pipe. So then when you call create process on find, you could say right there, connect find to the pipe. Okay, now what if it's not? Okay, now in that homework assignment, in that problem, you're comparing this guy to that guy. Okay, so let me save this picture. So this is 7A. Okay, let's draw a picture for 7B. It'll be a slightly different picture for 7B. Okay, in 7B, so CMD is still the parent. CMD is doing all the work. Okay, so the command we want to do now is something like, I want to sort well, okay, here. What that does is just gives me the help file from sort. Okay, so sort, if I type this command, it's telling sort, print your output, print your help to standard out. But then I want to put that into a pipe and then find all the letter X's in the output from sort. Okay, and there's 1, 2, 3, 4, 5 lines that had X's in them. Okay, now sort is not one of the built-in commands. If we go over here, go down here to sort, we see that sort's not one of the built-in ones. See, the built-in ones have a little dot after their name. Okay, so sort is not a built-in. So sort is a program. So that command line needs to create a process for sort and a process for find. So CMD is going to launch sort.exe, and CMD is going to launch find.exe. Actually, but before it does that, the order would be first it creates the pipe, because it needs the handles to the pipe before it can create these guys, because it needs the handles to the pipe to be able to put them in the startup information block. So it actually would create the pipe first. But what it's going to do is create a picture like this. Sorts output's going to be sent to the pipe, and the output of pipe is going to be sent to find. Okay, so this is going to be 1. This is this guy's standard in 0. Okay, this is a pipe. Pipes don't have names, so I just label them pipe. Now, where does sort get its input from? Here's a little bit interesting. Sort, we didn't say otherwise, so sort gets keyboard input just like CMD. So in fact, here's one way to think about it. The keyboard input's going to 2 places now. The keyboard input goes into CMD and into sort. What happens is CMD just doesn't pay any attention to it. It lets sort read it. Okay, so right now, the keyboard input in this picture, the keyboard input is actually going to 2 places. Okay, the keyboard input's going to 2 places. Command can read it because it needs to read it when the program's done. So like when this thing is finished, see, I'm back to now when it was running. Oh, well, sort didn't read anything that I typed from the input. See, sort didn't use standard input anyway. I'll change that to something that does need standard input. Okay, but sort didn't even use standard input. And then the output from sort went to the pipe, and then the output of the pipe went to find. Now the output from find will go to the console along with the output from CMD. Okay, so both CMD and find are sending their output to the console. But what happens here is that CMD actually goes in a loop waiting for find to end. You've seen how to do that in your homework. CMD will call wait for single object and it'll wait for find to end. Since they're sharing the output, CMD is not supposed to send in the output till find is done. It's going to let find do all its work. So you run this command. The idea would be let find do all its work. Then when find is finished doing all its work, then CMD can print a new prompt. So over here, CMD will launch find, and then CMD will wait for single object on find. When find is done and it goes away, then CMD knows it's safe to print to the console again. That's how CMD knows when it's okay for it to print to the console. So while find is running, just like in your homework assignment, this program goes into it blocks itself waiting on this to terminate. As soon as this is terminate, then this one can send that data to the console. So if your launcher program was specifically designed to make it mimic a lot of what CMD does. So your launcher program had that one case where it had to launch another CMD, but wait till it was done so that when it was done, it could go back and print another prompt. And that's how CMD itself works. CMD, it's doing just like what your launcher did. Okay, and this one's a 0 here. And then there's also all the standard errors in this case, all the standard errors in this example, they'd all be going to the console. So since not saying otherwise, all the standard errors in all three of these are going to the console. So if there was something wrong with sort, if sort had an error message to print, the error message from sort and the error message from find would both appear on the console, which it actually could be confusing. There's no real solution to this. The programs are supposed to print good error messages. So if their error messages get mixed up with other programs' error messages, you can kind of hopefully sort them out. But notice that when these guys are running, when sort and when you run this command line, if sort wants to print an error message, its output will get mixed up with find's error message. In fact, I can probably make them both give me an error message. Let me see. If you just type find, you get an error message. Okay. And if you just type sort, well, if you just type sort, it reads from standard input. So now it's sorting what I type as input. Then when I type Control Z, it sorts what I gave it. Okay. Let's see. Let's see. I'm trying to think about what I can do to give sort an error. Invalid switch. Okay. So sort Q, 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 and pipe it into find. See, both error messages appeared. Now, notice they goofed up sort. Can anybody tell me what they did to goof up sort? See, we just found a kind of a sloppy thing in Windows programming. What is sloppy here? Look at the output. Who sent what error message? What's the problem here? Come on, think. This is a good question. This is the kind of stuff as programmers, you got to start, as you work for a company and you can get real bonus points by noticing little things that aren't being done right and fixing them. So like somebody at Microsoft should have kind of noticed there's something a little bit funny here. Who gave me those error messages?
Find has the program name first and sort does not.
Yeah, so I don't know who gave me that error message, right? So they should have said sort : invalid switch. Just because the error messages are being mixed up in the count. See, the way this works, Linux is the same. The error messages are all going to the same place. All the standard errors are going to the same place in this case. Now I could do something different. I could redirect the standard errors to someplace else. But right now they're not. For example, tell this guy standard error to go to notice that the redirection symbol is this guy. But you put a 2 in front of it and you're saying redirect the 2 stream, not by default you redirect the 1 stream, but that says redirect the 2 stream. So that means that Q's error message should go to a file called errors.txt. Okay. Now, hit enter. Now, notice that error message is gone. Well, where did it go? Well, it went to, I'm in the folder classroom. I'm in the folder C users classroom. So I go here, C users classroom. And there it is. See, invalid switch. See that error message. Now, again, I don't know. Now if I'm reading that file and I see this error message, that's actually really bad programming. Error messages should always have some kind of little thing that says where they come from. So this should have said, it should have said find invalid switch. No, that was sort. I'm sorry, that was sort. Okay, it really should say something like this. It's just having an error message by itself is really bad programming style. So now this has probably been like this for 30 years in Windows, and they probably at this point don't want to change it. Why at this point would they probably not want to fix this? There's a quirky thing about the way people like companies like Microsoft work. At this point, why would they probably not want to fix the way sort sends out error messages?
Because they've made so many other programs that work with it working that way that they would have to change a bunch of other things too.
Right. At this point, probably thousands and thousands of programs have been written that look for error messages from sort a certain way. And if they fix this, they'd be breaking all those programs. So at this point, they're stuck with it, which is a good lesson. When you write code, get it right. Try to get it right at the beginning, because sometimes you don't have the option of fixing your mistakes later on. Once your mistakes get cooked in, you can have a hard time fixing them. That's one reason why Microsoft can be very conservative about releasing software or announcing the final version of a software. They go through iteration after iteration after iteration of beta versions and alpha versions because they want to try to find as many problems as they can before they give the official release. Because once you've released the official version, it can be painful to correct errors. Okay, so we see now that. Now, here's the difference between these two pictures, okay? The built-in command on one end of the pipe was CMD. See, the built-in command had CMD itself at the end of the pipe because the DIR, CMD did the DIR work. So it created a connection to the pipe and sent its output into the pipe to find. Whereas when you run a real pipeline, the CMD creates the left side of the pipe and the right side of the pipe as separate processes and sends the output of this process through the pipe into that process. Okay, so a pipeline, well, let's go back to the problem. A pipeline where one of the programs is built in is a pipeline. There's still a pipe, but there's only two processes, CMD itself doing this and that process. Whereas a normal pipeline where they're not built-in commands, you have CMD process, and that process. So you have three processes involved. Okay, so you can have so this is the normal pipeline with three processes involved, and this is the actually kind of the special case of a built-in command. So the built-in command sits at one end of the pipeline. You can also create another example where there's a built-in command that sits at the other end of the pipeline. I'm not sure what an example of that would be, a built-in command that you would put at this end of the pipeline. You'd have to go back to that list of built-in commands and see if there's one that would play a role at the I can't think of one of the type. No. most of these would not work well on the right-hand side of a pipe because they don't read any data. They produce, most of these produce data. They don't read data. So almost all of these are programs that, like date gives you the date. You know, most of them are things to produce data, not read data. So they are better at the left end of a pipe. They don't work very well at the right end of a pipe. Offhand, I don't know of any one of these that would work on the right end of a pipe. Okay. Oh, there's one, echo. Echo oh no, echo doesn't read from standard input. Echo only reads from the command line. So echo takes whatever you type on the command line and just echoes it. Okay. So it doesn't read from standard input. So if you just type echo by itself, it just tells you the echo is on. Okay. So it doesn't read. Yeah, there's very few of these built-in commands that read from standard input. Probably the only one is type. The type command. No, again, it doesn't read from standard input either. No, so maybe none of these read from standard input. There may not be any of these built-in commands that read from standard input. Okay. So that would make it hard to put one of them on that make it hard to put a built-in command on the right-hand side of the pipe. So maybe there aren't any that can go on the right-hand side, but there's a whole lot of them that could go on the left-hand side of the pipe. Okay. All right. So these are this is, let me save that. Okay, so there's the two versions. And this is a nice problem. Understanding how CMD works is a big step in understanding how to work with the command line. Like if you end up with a job where you have to work with command lines, it really helps to know that this is what command lines are doing. That, when you type command lines and you pipe things between, you type command lines with pipes, it really helps to know that you're really launching one process and another process with a pipe object between them, and you're connecting the standard out of this one to the pipe and the output of the pipe to the standard in. That the CMD is actually sitting here waiting. It's actually waiting on that end of the pipe. When that end of the pipe terminates, that's when the whole pipeline is terminated. This end of the pipe doesn't matter, because this end of the pipe can terminate, but this thing could be still processing data so this thing could read a bunch of data, send it to here, but find might still, and then terminate, but find might still be working. So there's no reason why when this one ends, this one has to end. This guy could have a whole buffer full of data that he's crunching on while this thing is quit. So CMD waits on find. It only waits on find. And then when find terminates, CMD will come back. If for some reason find terminates before sort does, it doesn't really matter. Sort's data will just go into the pipeline, and sort will eventually probably realize that the pipeline's not reading thing, and sort will just quit. But since if find disappears, there's no data from here that can flow to the console, so CMD can go ahead and use the console. Sort will just be stuck. In fact, if find quits before sort does, more than likely sort will just get stuck. It'll probably just get blocked infinitely, and it'll show up. Sometimes you find these processes in your task manager that are just stuck. You would find it possibly as a stuck process in the task manager. A process that's just sitting there running, but you don't know what it's doing. It actually could come from, for example, a pipeline where this end of the pipeline goes away, and then sort just is stuck trying to put stuff in the pipe, but no one's emptying the pipe, so sort just gets stuck there. Sometimes called a deadlock. Okay, so that can happen. If sort goes away first, find will just keep working on what data it has. Okay, unless find is waiting for more data. Well, no, if sort goes away, the pipe gets closed, so find realizes that there's nothing left here, so it sees essentially an empty file. So if find is working until it sees an empty file, when sort goes away, sort closes, the pipeline closes, and find thinks that this is an empty file. So find should stop. But if find goes away, sort doesn't have a way of knowing that. So sort can get stuck trying to write to a pipe that's full and the pipe is stuck because nothing's going to be emptied out of it. So sort can get stuck, but find shouldn't. Okay, so that's the kind of thing. If you know this picture, you can understand, for example, that it's possible for sort to get orphaned. It's possible, or get deadlocked. It's possible for this guy to get deadlocked if this program should crash or something should go wrong with it. If something goes wrong with this program, it could leave this one deadlocked. The other way doesn't really happen. If this one crashes, then the pipe closes automatically by Windows, and this guy sees an empty file over here, an end of file, so it would terminate. Okay, so these pictures are useful. They're useful for understanding like little things like what the command line's doing, just little things like that. It's useful for understanding little things like this. Okay, and if I do this, what's happening now is what's happening here? If I'm going to this picture, sort is reading from standard input. See, I didn't tell sort what to sort. So if you don't tell sort what to sort, it sorts from standard input. So now I'm waiting at standard input. Okay, now sort is just building up data at this point. So sort needs to sort the data. So it has to wait till it sees all the data before it can send anything down the pipe. Because what's it supposed to send down the pipe first is the thing that would be in the sorted at the beginning of the list. So like the D will come before the S, but the S will go to the end of the list. This A line should be at the top of the list, but sort doesn't know that until I tell it no more input. As soon as I tell it no more input, sort will do the sorting and send it all down the pipe. At that point, now find right now is just waiting for data from this pipe. There's nothing in the pipe. So if you think in this picture here, sort is sending its data down the pipe to find. Sort's reading from the keyboard, but sort's building up a buffer in here of all the data so they can sort it. Then when it's sorted all the data, it'll send it down the pipe. Meanwhile, find right now is just waiting for something to show up at the pipe. So find is just waiting for data. As soon as I type Control Z, what happened? Oh, I didn't type any X's in there. I should have paid attention. Sort sorted it. Let me do it again. Okay, here's a Z with an X in it. Here's an A with an X in it. Here's a W with an X in it. Here's a B with an X in it. Here's a Q with an X in it. Now, notice that sort, now all those lines will show, okay, and here's a R with nothing in it. Here's an S with no X in it. And here's a U with no X in it. Okay, so what's going to happen? Sort's going to sort these. It's going to sort them in alphabetical order. So the A line will be before the B line, blah, blah, blah. Then it'll send it to, then when I type Control Z, sort will sort it all. And then find will find the lines with X's in them. But notice that they're found in sorted order. Okay, so sort had to wait till it had all the data. Then when it had all the data, then it could sort it. Then it could just blast it all into the pipeline. And then find would then process the data and output only the lines that began with X, that had X's in them. Okay, but we see that they're sorted out here. But if you're thinking, if somebody asks you what's the computer doing right now, what it's doing right now is it's in this picture. Sort is reading from standard input, waiting for you to type stuff in. As you type stuff in here, well, what's happening? Well, nothing seems to be happening. Well, sort has to build up all the data inside of itself first. It can't send anything down the pipeline because it doesn't know, like right now, it doesn't know that maybe there's going to be a line B that comes after the A. Okay, so there's something that comes after the A. It won't know that till it sees the B, and then it won't know what's coming next. So it has to see all the data before it can sort it. Then, so find is just sitting here waiting. Oh, and if I call up Task Manager, there's find waiting. See, find is running. So, in our picture here, we should see CMD, sort, and find are all processes. So CMD is that guy, find is that, and sort is there. Okay. Now, if I go up here, let's see. See, look at the command line. See, the command line on find was find X. See, it's real nice. Task Manager shows you a lot of stuff. It's really useful if you know where to look. So that, that is that command line. So that command line got broken up into a left side and a right side. Create process created that right. Create process created this with find, with that command line, find X. Okay, so this side of the picture was created by this guy calling create process with a find. In fact, I could have put it in here. There was a find X. That's the actual command line there. So see if I can get it to draw it look nice. Okay, so that's the command line, find X. Okay, and you see it in Task Manager. Task Manager shows you that find was created with that command line. Now sort, I didn't give it any command line arguments. So sort was just created with the command line sort. Because I didn't give sort any option. I could have given an option saying to sort in reverse alphabetical order instead of regular alphabetical order. So I could have put like if you type sort /?, sort tells you what its options are. And /r for reverse. So go here and type /r. Okay. Now if I go in Task Manager, there's sort. See, now it's created. The command line is sort /r because this CMD read this command line, and CMD started sort using create process with that command line, and CMD used create process to create that command line for find. Okay, which so you can imagine how that's done because you've done that pretty close to that in your homework assignment. So you've used create process to create processes with command lines. So CMD reads that command line, breaks it up into two pieces. It takes that part and makes a command line for create process, and takes that part and makes it a command line for create process. And what you don't know is how to make that pipe in between. We haven't seen how to write that code, but there's code to write to create that pipe in between those two. Okay. All right. So these pictures are really useful if you want to understand how this stuff works. These pictures really, like if you read a book on Linux, if you read a book on Introduction to Linux, you'll see these pictures when they're explaining command lines. Some of the textbooks will draw these pictures to help people understand what else. Now, Linux makes much more use of the command line than Windows does. So Linux books are much more likely to teach these kinds of ideas, and that's where these pictures, the idea for these pictures comes from, is a lot of the introductory Linux books draw these pictures to help people understand what a command line is. Okay, okay. So these are real good. I think these are real good problems. I hope you spent time thinking about them. They're not. It's the kind of thing it's worth learning at some point in your career. These are really, there's no real point in our course. We don't have, this is not part of operating systems course. I think it's a real good place. It's a good time to learn it. It's kind of useful to learn it, but you could easily teach the operating system course and never mention any of this stuff because it's not part of the theory of operating system. It's got nothing to do with scheduling and virtual memory, but at the same time you're learning how to create processes, which is part of operating system. You could at least start seeing, oh, that's how CMD works. CMD just does what you did in homework assignment 2, for example. So, the create process is part of operating system, but then seeing how create process gives you information about how a tool like CMD works, that's what's real nice, is to actually use the operating system class as a chance to introduce really important ideas about computer science, about day-to-day programming. How to use your tools, how to understand how these tools work. Okay. All right. So we'll quit there. Okay. And then, like I say, so on Wednesday, if there's like more questions about some of these review problems, we could do a couple more of these. Or then we'll start talking about, remember, in terms of scheduling, we're talking about the round robin. So we're going to go back and talk about round robin and then multi-level feedback queue. So that's on Wednesday. If there's any questions, we can do some more problems. Otherwise, we'll start talking about round robin and multi-level feedback queue. Okay, but we run out of time, so we'll quit for now. Okay, anybody had a last second question? Okay, I'll put these pictures up on the course website as what we did today. So you can look at them and see it. Yeah, save. You can see these pictures and remind yourself how they work. Okay. All right. So meet on Wednesday. I'll go ahead and stop. Any last question? Any last second question? Okay. Okay. See you on Wednesday. Bye.